Welcome back to my channel. In this lesson, we are considering a subtopic under atomic structure, isotopes. If you're joining us for the first time, we welcome you specially. This is a place where we learn the basics of chemistry step by step. So do well to check our previous videos. If you look at your screen closely, you see that there are questions on your screen right now. Are they familiar? Are they something you can answer? But not to worry, by the end of this lesson, you will be able to answer these questions and more. So get your writing materials and let's get started. What is isotopes? Isotopes are atoms of the same element that have the same atomic number. You can say same number of protons, but different mass numbers or different numbers of neutrons. Example, carbon-12 and carbon-14. Both are carbon atoms and both have 6 protons, also atomic number 6, but they have different number of neutrons and also mass numbers. Why isotopes are different? Isotopes have the same number of protons but different numbers of neutrons. They have the same number of protons but different number of neutrons. Remember, atomic number is the same thing as number of protons, and mass number is equal to protons plus neutrons. So therefore, a change in the number of neutrons changes the mass number but not the element. A change in the number of neutrons changes the mass number but not the element. So isotopes of the same elements have the same atomic number but different mass numbers. They have the same atomic number but different mass numbers. Examples of isotopes. Here are some examples of isotopes. We have hydrogen with proton 1, neutron 0, mass number 1. We also have another hydrogen, another isotope of hydrogen with proton 1, neutron 1, then mass number 2. And another isotope of hydrogen, proton still 1, neutrons now 2, mass number 3. So if you check very well, you see that the variation in the number of neutrons will change the number of mass number, but the number of proton remains the same. So that is why we say they are all carbon of the same element, hydrogen, with the same atomic number 1, but have different mass numbers due to the variation in the number of neutrons. Hope you are following. Now, another example is carbon atom. Atomic number of carbon is 6. And the first isotope of carbon there has 6 protons, 6 neutrons. Therefore, the mass number, which is neutron plus proton, is going to be 12. But for the second isotope of carbon there, it has 6 protons, 7 neutrons. Therefore, the mass number will change and it's going to be 13. Also, for the third isotope of carbon, we have 6 protons, 8 neutrons, mass number 14. So their proton, number of protons remains the same, meaning the atomic number, atoms of the same element with the same atomic number but different mass numbers as a result of change in the number of neutrons. Hope you are following. Now let's look at properties of isotopes. You should note that isotopes of an element have the same chemical properties because they have the same number of electrons. Number 2, they have similar chemical behavior, but some physical properties differ because their masses are different. So we said they have similar chemical behavior, but some physical properties differ because of their masses are different. Now, isotopes occupy the same position in the periodic table because they have the same atomic number. This is very important. They occupy the same position in the periodic table because they have the same atomic number. Like we've always said, isotopes differ only in the number of neutrons, not in the number of protons or electrons. Now let's look at uses of isotopes. Number 1, carbon-14 is used to determine the age of ancient remains and fossils. Number 2, cobalt-60 is used in the treatment of cancer by destroying cancer cells. Number 3, iodine-131 is used in the diagnosis and treatment of typhoid disorders. Number 4, uranium-235 is used in nuclear reactors for the production of nuclear energy. Note, the relative atomic mass of an element can be calculated from the masses and abundances of its isotopes. Let's take a summary of what we've learned so far under isotopes. We said isotopes are atoms of the same element with the same atomic number but different mass numbers. They have the same number of protons and electrons but different numbers of neutrons. Isotopes have similar chemical properties but some physical properties differ because their masses are different. They occupy the same position in the periodic table because they have the same atomic number. Isotopes are stable or unstable radioactive. Let me take that again. Isotopes are stable or unstable radioactive. Unstable isotope emits radiation and change into other elements. We said the relative atomic mass of an element can be calculated from the masses and abundance of its isotopes. So we'll be stopping here for this lesson. But now, before we go, as usual, let's visit those questions that we saw earlier. Number 1, which of the following isotopes is used to determine the age of ancient remains? Which of the following isotopes is used to determine the age of ancient remains? Iodine-131, B, cobalt-60, C, uranium-235, D, carbon-14. And the correct answer is carbon-14. Number 2, isotopes of an element have the same atomic number because they have the same number of dash. A, neutrons, B, electrons, C, protons, D, nucleons. And the correct answer is C, protons. They have the same atomic number because they have the same number of protons, C. Now your turn. The relative atomic mass of an element can be calculated from the masses and abundances of its isotopes because of dash. A, isotopes occupy different positions in the periodic table. Isotopes have different atomic numbers. Isotopes have different chemical properties. Isotopes exist in different natural abundances. So you write the correct answer in the comment section. Thank you for watching. If you found this video helpful, do well to like, subscribe, and share. You can actually be helping someone. That child is always complaining that chemistry is hard by sharing this piece of video with someone. Thank you once again. We'll see you in our next lesson. Bye.